So this matrix is in row echelon form. And remember, these wildcard entries could be absolutely anything. I could replace this asterisk with, say, a 2, this one with a -10, and this one with a 1.3. Any real numbers at all could be in place of these wildcard entries, and this would still be in row echelon form. Let's do one more example. So this is going to be another 3 by 4. The first row, I'm only going to specify the first entry. It's going to be a 1. The second row will look like this, and the third row will look like this. So let's check that this matrix is in row echelon form. So first condition, check that all the rows of zeros must be at the bottom. And there are no rows of zeros, so you can check off the first condition as automatically being satisfied. The second condition says that the first non-zero entry of each row must be a 1, so circle the first non-zero entry of each row and make sure that they are all 1s. And certainly they are, right? The first non-zero entry in each row, they're all equal to 1s. And third condition, each leading 1 must be to the right of every leading 1 above it. So, and that's true, right? This doesn't have any leading 1s above it, so there's nothing to check. This one, there is a leading 1 above it up here, and this leading 1 is to the left of this leading 1. This leading 1 down here has 2 leading 1s above it, and it is to the right of both of them, right? This leading 1 is to the right of both of these 2 leading 1s. So that's why this third matrix is in row echelon form, and hence all 3 of them are. So I'm going to take advantage of the abbreviation and say these are in row echelon form. And just a reminder, this asterisk is a wildcard entry. It could be absolutely anything. I want to separate this from the next list of examples because now we're going to look at some examples of matrices that are in reduced row echelon form. Now, ask yourself, let's start with this one. Is this matrix in example A in reduced row echelon form? And the answer to that is it depends. It depends on this entry up here in the top right corner. Because the first leading 1 over here, remember condition 4 says, and this is what you need to check if you want to check whether a matrix is in reduced row echelon form, if you already know that it's in row echelon form, which we do, is you need to check that every leading 1 is the only non-zero entry in its column. And that works just fine for this one, right? This leading 1, the only other entry in the column is a 0 right below it because columns are vertical. But this leading 1 might not be the only non-zero entry in its column, depending on what this asterisk is. So if we, instead of having a wildcard entry here, if we replace this with a 0, then we can actually say more. Now this matrix, we can say that this is in reduced row echelon form because both of the leading 1s are the only non-zero entries in their column. So this one might not be in reduced row echelon form, but this one is definitely in reduced row echelon form. Let's do the same thing for the other 2. What would we have to change about this matrix up here to make sure that it's in reduced row echelon form? And we only need to worry about the fourth condition because we've already checked that the first 3 apply. So this leading 1 is already the only non-zero entry in its column because we've got zeros down below. But this leading 1, well, there's a 0 down here, but this asterisk up here, this is not specific enough. This needs to be a 0 up above it in order for this matrix to be in reduced row echelon form. So that's what we need to change for this one. So we'll have 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, and then we can still have these entries be wild. These could be absolutely anything, and this would still be in reduced row echelon form. Now the third example over here, we would actually need to change 3 entries to make this matrix in reduced row echelon form. All 3 of these asterisks up here would need to be replaced with zeros to make sure that these 2 leading 1s are the only non-zero entries in their columns. This leading 1 already is, right? These 2 zeros, they are what we need. But for these 2, we need all 3 of these to be 0 as well. Now these 3 entries in the fourth column, we don't care what they are. They won't cause any problems, so we can leave them be wild. So we can fix this one, or not fix it, but replace it with a different version of itself that we can say more about. We can say it's actually in reduced row echelon form, is the following. I better start a little lower. I'm going to crash into this down here. So I'll put it down here. So we can have 1, 0, 0, a wild entry there, 0, 1, 0, this one can still be wild, and then 0, 0, 1. So these three matrices are in reduced row echelon form.